Scenario. In a physics lab, a group of students are provided with a lab equipment to study the motion of a pendulum. Question. Before the students could set up the lab, they are tasked to determine the acceleration due to gravity that acts on the pendulum as it swings in simple harmonic motion. Derive that equation. Answer. You're going to use the period equation for the pendulum in simple harmonic motion. In the formula sheet, for a pendulum, the period is t is equal to 2 pi square root L over g. Divide 2 pi to both sides. Squared both sides to get rid of the square root. You get t squared divided by 4 pi squared now equals to L over g. Cross multiply. No, I don't cross multiply. I just flipped everything upside down. Now I cross multiply. So I multiply L to both sides. I get g is equal to 4 pi squared times L divided by t. Question. What should be graph? That is asking what should be on the x-axis, what should be on the y-axis, and how should the graph be used to determine the acceleration due to the gravity of the pendulum. The answer. We're going to use the answer from before. I'm just going to pull it out. The reason why I pull out the 4 pi squared is because that is a constant. No one cares about that. The only variables that you care about is that there is an L on top and a t squared on bottom, and that is going to be equal to g. This should remind you like the slope equation. The 4 pi squared again is the constant. What goes on top is your delta y, which is on bottom, which is your delta x. So on the x-axis, it should be the period squared. On the y-axis, it should be the L, which is the length. If you take that slope of that graph, you're now going to get the gravity. The next question asks to fill in the value of the chart for the setup for that lab. The only two variables that you have here is the length of the string, which is the symbol L. That equipment that you can use is going to be a meter stick. The next is the period for one revolution. The period symbol is t. The unit for a period is second, so you're going to use the device to measure it in seconds, which is going to be a stopwatch.